If there is a displacement due to a particular on application of the force, then you can say that work is said to be done. Okay. If I am applying a force on a body like this, there is a block or a body like this. On this one, if we are applying a force and there is some displacement in the body from point A to the point B, that the displacement will be S. So due to the application of this force and this displacement has been happening, then you can say that work is done. So work done is equal to, work is a scalar quantity and which is F bar dot S bar. It can be the component of the force, in the sense it can be F cos theta into S, or it can be F into S cos theta, where theta is the angle between the force and this one. So in the same example, the mg is also the force which is acting in the downward direction. Now, what is the work done by the gravity here? Work done by gravity. So can anyone go for this one? Work done by the gravity is how much? So the mg is acting in the downward direction. Is mg causing any displacement in the body in moving from A to B? No. So work done by the gravity is equal to 0. Technically, I have written it as a 0. Now look at in the mathematical perception, that is work done will be equal to the W is equal to Fs cos theta. The angle between the F and S, how these two are, F and F bar and S bar are perpendicular, in the sense theta is equal to 0 degrees. So work done cos, 90 degrees. So cos 90 is equal to 0. So work done because of the gravitational force is 0. Okay. So the SI units for this one is going to be the joules. And you know that CGS units are going to be ergs. What is the relation between them, Nana? 1 joule is equal to 10 to the power of 7 ergs. So please be careful for the conversion in this case here. So if a body is working against the gravity, first one if I write, so that is work done against, it's a negative work done against gravity is, that means the gravitational force in the downward direction, you are lifting it in the upward direction. So it can be written as an work done is equal to minus mgh. That means you are lifting a block from the surface to certain height. So mg is in the downward direction, but your displacement h is in the upward direction. So both of them are in the opposite direction, 180 degrees. That means cos 180 is minus 1. So it's a negative work done. Next, what is the work done in moving the body? Oh, that is work done in moving a body with velocity. So that means a body is, you are making a body to move with certain velocity. Then work done will be in the form of kinetic energy, which is half mv square. Okay, so like this. So next important point, you can write it as an area of force and displacement graph gives what? Work done. సో ఎంత వర్క్ జరిగింది అనేది ఇస్తుంది ఫోర్స్ కిను డిస్ప్లేస్మెంట్ కి గనక మనం గ్రాఫ్ గీస్తే. అదే విధంగా సపోజ్ ఫర్ ఎగ్జాంపుల్ హియర్ there is a block here placed on a rough horizontal surface. Now, how much amount of the work I need to do to move the body? There is a coefficient of friction mu. So that means work done by friction. This is work done by friction. So what is this work done by friction? Can be written as an frictional force into displacement, that is static friction into displacement, which is, you can write it as an mu mg into displacement is less. That means you are moving a block against the frictional force. So it is also a negative force. Okay. It is also a negative force. Everybody, can you hear me, Nana? Yeah. Right. So next one, please. So next type of the work done. So there will be like this. There will be a different types of the work done. So ain't different types of the work flow. For example, if I go for the another case like this, if a rod is been hanging, if a rod is hanging, what is the amount of the work done in lifting this rod by an angle theta? There will be obviously two types of the forces to move this one. One force might be acting in this direction. Another force will be gravitation. You are rotating it by an angle called as a theta. This is the location of the center of mass. So you are lifting it to certain height. For example, this will be the height h that you are lifting it. Height is h. So work done height value I don't know, but this value is going to be the length L. Suppose this point is O, this point is A, and this point is B. It's a right angle triangle, and so from this one, cos theta can be written as an adjacent side is L minus H, that is OA. OA by hypotenuse is OB. OA is L minus H by L. From this one, H can be calculated as L into 1 minus cos theta. If I go to the center of mass location, it will be L by 2. For simple pendulum, you can take it as an L into 1 minus cos theta. So as we have got the H value, so work done will be equal to the how much? mgh. So that is mg into L by 2 into 1 minus cos theta if this is for a rod. And if it is for a simple pendulum, so for the simple pendulum, same formula, but the bob will be having, so rope doesn't have center of mass location, or the center of mass of the system will be at the bottom, so it will be mgl into 1 minus cos theta. What is the work done by the heat? If I give some heat to a container and the piston moves, so how can I give the work done over there? So work done on a gas or by a gas is equal to, that is P into dV, pressure into change in volume. So like this you can write this one. Okay, so they depend upon the situation, the work done can be written in the different formats. That is work done in compressing or elongation. Then the work done can be written as an, it is in the form of half k x square, where x is a compression or elongation. So different models like this. Next one, work done in pulling a chain onto a table. Work done in pulling a chain of length L, on, or total length is L, comma, if L by nth part is hanging, L by nth part is hanging, then to move that particular thing and have to move the hanging part onto the table. W work done is equal to, that will be equal to your mgl by 2n square. So you can derive this one, for example, in this way. So out of the total length, if the hanging portion is being some total L by nth part is hanging like this. So the general formula is going to be the mgh only, na? So that means how much part is been hanging. So how much part is been in hanging means this is the part which she has been hanging, whose mass can be m, but the center of mass of the hanging portion will be lies at the midpoint of that one. So it will be the total mass by the mass which is been hanging m by 2 into nth part will be hanging. This is the mass of the hanging portion. G will be there into height. You need to lift it is going to be the L by N. So this will be the mgl by 2n square like this. This represents your h. It is the mass of the hanging portion. So like this, you can be able to find out the different cases. Work done by the gravity if I want to move a satellite to a height h. So work done in moving a satellite or a planet to height h is, so from the surface if you are lifting, work done is equal to, it can be written as an mgh into 1 plus h by r. So this is the work done where h is going to be the very less than r. Under this condition it will be working. Everybody knows work done by the in moving a charge is how much? Everybody knows this one. Work done in moving a charge. In moving a charge. Second year concept. W is equal to potential into charge. Okay, so these things we know. Work done in rotating a magnet. So wherever you want, you can use this work done in the different situations and different scenarios. Work done in rotating a bar magnet is, it's going to be the mb into cos theta 1 minus cos theta 2. Work done for a rotating a dipole is going to be pe into cos theta 1 minus cos theta 2, like that.